And now we look at a couple of rules for radicals. We will look at the product rule and then the quotient rule. So given those two radicals here, the nth root of a times b will be the nth root of a times the nth root of b. So we've seen this before. This should not be hard to work with at all. So here's an example. We have 256 times a to the 21st power times b to the 37th power, and then it's the 7th root of all that. First thing we can do is change this to 2 to the 8th power, so we see everything as exponents under here. Then we break this up. 8 is not a multiple of 7, but 7 is, so we break this up into 2 to the 7th times 2. 21 is a multiple of 3. 37, we break this up into 35 and 2. And then we apply this rule here. So we had looked at this before. So we keep these in here because these exponents are all multiples of the index. And over here we work with the factors that remain, the 2 and the b squared. Of course, then this becomes trivial. 7 divided by 7, 1, so this is 2 to the 1 power. 21 divided by 7 is 3, so this is a to the 3rd power. 35 divided by 7 is 5, so this is b to the 5th power. And of course, you are left with the 7th root of 2b squared. So you can always just work with the shortcut here. You could write from here, simply say, so you don't necessarily have to break this up like this, but you should be aware of this possibility. So 8 divided by 7 is 1 remainder 1, so both of these have powers of 1. 21 divided by 7 is 3. 37 divided by 7 is 5 remainder 2. And we're done. So let's look at these examples here. 10 divided by 8 is 1 remainder 2. 19 divided by 8 is 2 remainder 3. 26 divided by 8 is 3 remainder 2. If we look at this one, 11 divided by 6 is 1 remainder 5. 15 divided by 6 is 2 remainder 3. And 9 divided by 6 is 1 remainder 3. And if we come here, 7 divided by 3 is 2 remainder 1. 5 divided by 3 is 1 remainder 2. And 8 divided by 3 is 2 remainder 2. So these are very easy, and I have no problem with you using the shortcuts. Just be aware of what the shortcuts are cutting short. In case you ever have some difficulty, you understand what's going on. So here is the quotient rule, and it's very similar. Nth root of a quotient is equal to the quotient of those roots. So here we have an example again. 32 x to the 5th, y to the 4th. We can break this up into the 3rd root of the numerator and the 3rd root of the denominator. And here we can do this fairly quickly. We can simply say 5 divided by 3 is 1 remainder 2, and 4 divided by 3 is 1 remainder 1. And of course, 5 divided by 3 is 1 remainder 2, so this is 2 to the 2nd power. And 6 divided by 3 is 2. And this we can write it over on the side. So let's look at some examples here. The first one, this we can write this as 2 to the 7th, and so 7 divided by 2 is 3 remainder 1, so notice there's a 2 to the 1 power here, and 9 divided by 2 is 4 remainder 1. And then down here, notice we broke this up into square root of the numerator and square root of the denominator, and this 3 divided by 2 is 1 remainder 1. And so we can then write this as what we have here, and these two we can put back under a single radical sign. So whether you prefer this or this, it depends on the problem you're working with and what is convenient. So the reason why you're learning all of these things is that in future courses, when you need to solve problems, you can maneuver yourself, you can manipulate these expressions to get the form that you need. So here, once again, this we express it as 2 to the 5th power. We break this up into the cube root of the numerator and the cube root of the denominator, and we're off to the races. 5 divided by 3 is 1 remainder 2. 9 divided by 3 is 3, no remainder. So notice there is no x under here. And 3 divided by 3 is just 1. Or as we said in the past, when these are the same, well then you just are left with the y. And this then you can write as 2x cubed over y, and then this is the cube root of 4. If we look at this one, a to 1 is 3 to the 4th power. And once again we have the 4th root of the numerator and the 4th root of the denominator. So 4 divided by 4 is 1, so the 3 is out here just like that. And 7 divided by 4 is 1 remainder 3. And then here, 9 divided by 4 is 2 remainder 1. And then we rewrite this. 3x over y squared, and then we put this back under a single radical sign. So I hope you're seeing that this is a fairly easy thing to know. You just need to practice a few. Again, we apply the radical to the numerator and the denominator. But first we do a little bit of simplification. So if we notice this is 4 squared and 3 squared, and then this p to the 7, we say 7 minus 3, that leaves us with p to the 4th. And then down here, well, that's 5 minus 2, 3. You could also say 2 minus 5, but then that would be q to the minus 3, which is 1 over q to the 3rd power. So any way you do it, you end up like this. And then we apply the square root to the numerator and the denominator separately. And so the square root of 4 squared is 4, the square root of p to the 4th is p squared. Notice 4 divided by 2 is 2, 2 divided by 2 is 1. And here, 2 divided by 2 is 1, we're left with 3, 3 divided by 2 is 1, remainder 1. And this is pretty much it. You could write this as 4p squared over 3q times 1 over the square root of q. But I think this looks good as it is here. So we're here at the last one. What we do here, well, we know that 3 into 3, 1, 3 into 48, 16. Then this is 13 and 5, that gives us 8. 13 minus 5 is 8. And then 6 minus 2 is 4. And then we apply the 4th root to the numerator and the denominator separately. And so then 8 divided by 4 is 2. And then here 4 divided by 4 is 1. 4 divided by 4 is 1. Or as we said earlier, if these are the same as the index, then it's trivial. You just have 2 and b. And we're done. So I hope this introduction to radicals has been of some use to you. Thanks for your attention. Bye.